In the following circuit, the resistance of resistor 1 is 10.0 ohms, resistor 2 is 25.0 ohms, resistor 3 is 90.0 ohms, and resistor 4 is 45.0 ohms. What is the equivalent resistance between points A and B? So in this problem, we have 4 resistors, each of different resistances, and we want to replace these 4 resistors with a single resistor that is equivalent to them, equivalent by having the same resistance as these 4 resistors. Notice that these 4 resistors is in a combination of parallel and series resistors. So what we have to do is we're going to have to break down this circuit into a simpler and simpler circuit such that we could determine the equivalent resistance. Let's begin this problem with our own sketch. We have the resistor 1 is in series with a combination of 2 resistors that are in parallel with each other. Those 2 resistors are resistors 3 and 4. And this combination on the left is in parallel with a single resistor, resistor 2, that's on the right. And we want to replace these 4 resistors between points A and B with a single equivalent resistor. So let's label these resistors R1, R2, R3, and R4. Let's note that resistor 1 is a 10 ohm resistor. Resistor 2 is a 25 ohm resistor. Resistor 3 is a 90 ohm resistor, and resistor 4 is a 45 ohm resistor. We will be solving this in terms of variables, and to simplify our work, I am going to express each of the resistors as multiples of a single resistor. So I'm going to choose R1 to be the resistor that we express the other resistors as a multiple of. So I'm going to call R1, I'm just going to call that R. Notice that resistor 2 is 2.5 times the resistance of resistor 1. So I'm going to indicate that as 5/2 R, because 5/2 is equal to 2.5, and 25.0 is 2.5 times 10. R3 is 9 times the value of resistor R1. And R4 is 9/2 times the resistance of R1. So now when we end up using these resistors in our equivalent resistor, we'll be able to simplify our algebra a bit. Now to begin, let's focus on the different components that we have in this circuit. The first thing I notice is that resistor R1 is in series with the combination of R3 and R4. So let's take R3 and R4 and make that into an equivalent resistor. So I'm going to do a series of diagrams illustrating our steps. So we have resistor R1, and that's going to be in series with the combination of resistors R3 and R4. And this combination is in parallel with resistor R2. And notice R1 and our equivalent resistors between R3 and R4 are in parallel. So we can replace that combination with an equivalent resistor. And that equivalent resistor I'll just call R1, 3, and 4. And that's in parallel with resistor R2 between points A and B. And finally, those two resistors in parallel can be replaced by a single equivalent resistor between points A and B. And that single equivalent resistor is based off of the parallel combination of resistor 2 with resistor 1 with 3 and 4. So this is going to be our sequence of steps. We're going to first find the equivalent resistor between the parallel combination of R3 and R4. Then we're going to find the series combination of those two. And when we find the series combination of those two, we'll then be able to take the parallel combination and end up with our final equivalent resistor. So let's start with the equivalent resistance for the resistors R3 and 4 in parallel. Now remember, for resistors in parallel, and let's write that down, the equivalent resistance of resistors in parallel is equal to the sum of the reciprocals of the individual resistances, and then we're going to have to take the reciprocal of that. And let's go ahead and do the equivalent resistance for resistors in series, which is a lot easier. For resistors in series, we just take the sum of the individual resistances. So let's do the parallel combination of resistors R3 and R4. Because resistors R3 and R4 are in parallel, we're going to take the sum of their individual resistances, and I should say the sum of the reciprocal of their individual resistances, and then we're going to take the inverse of that. This becomes R4 plus R3 over the product of the two resistances, R3 and R4, and we're going to take the reciprocal of that. And this ends up being R3, R4 over the sum of the individual resistances. Now remember, we said that resistor 3 has 9 times the resistance of resistor 1. We said that resistor 4 has 9/2 times the resistance of resistor 1. Let's simplify this a little bit by multiplying the top and the bottom by 2. And what that allows us to do is that allows us to clear a 2 in the numerator. And in the denominator, we're going to clear a 2 from the second term, and we're going to be left with 9 times 2 for the first term. So what this becomes then is 81R squared in the numerator, and in the denominator we have 18R plus 9R. We see that we have an R in the denominator can cancel with an R in the numerator. We have 81 over 27R. And so our equivalent resistance for the resistor R3 and R4 in parallel ends up being equal to 3R. Great, so now we can replace that parallel combination of 3 and 4 with the single resistor of a value of 3R. So our combination now is a series combination of R1 and R3 and 4. And that series combination is in parallel with resistor 2. So the next thing we need to do is to find the series combination of the resistances for R1 and R3 and 4. So in other words, find the equivalent resistance of that. And since R1, 3, and 4 are in series, we could just simply sum them. So we have the equivalent resistance for the resistor R1 and the resistors 3 and 4 is simply equal to the sum of the resistances for resistor 1 and the equivalent resistor R3, 4. Now remember, the resistance of resistance 1 we said is R. And the equivalent resistance for the parallel combination of resistors 3 and 4 we found to be equal to 3R. So this means that our new equivalent resistor combination of those two resistors in series is equal to 4R. Now we can take that equivalent combination and we should recognize that that equivalent combination is in parallel with resistor R2. And so we do this process again. We find the equivalent resistance for the parallel combination of resistor R2 with the equivalent resistor R1, 3, 4. So I'll write that down as R sub 2 and 1 and 3, 4. And since they are in parallel, we're going to take the reciprocal of the sum of the reciprocals of the individual resistances. So this is equivalent to R1, 3, 4 plus R2 over the product of R2 and R1, 3, 4. We have to take the reciprocal of that. So the equivalent resistance between those is equal to R2 and R1, 3, 4 divided by the sum of the resistance of R2 and the equivalent resistor R1, 3, 4. R2 we said was equal to 5/2 R1. We found the equivalent resistor R1, 3, 4 to be equal to 4R. And in the denominator, we have 5/2 R plus 4R. To simplify things a little bit, let's multiply the numerator and the denominator by 2 over 2. So in multiplying the numerator by 2 over 2, we get rid of a 2 in the numerator. And by multiplying the denominator by 2, we get rid of a 2 in the 5/2 term, and the 4R is going to be multiplied by 2. So that gives us the equivalent resistor combination, which I'll just simplify that now as just R equivalent, is equal to, well, the numerator is 20R squared, and the denominator is 5R plus 8R. An R in the denominator cancels with an R in the numerator. We have the equivalent resistance now is equal to 20 over 13 R. A very simple expression. So plugging in the value for R, we have 20 over 13 times 10.0 ohms. And when I plug that into my calculator, I get an equivalent resistance being equal to 15.4 ohms. So in this problem, we were able to replace those 4 resistors with this single equivalent resistor. And this is a very useful thing to be able to do. Let's say you have a circuit and you need a particular value of resistance. Well, by doing various combinations of series resistors and parallel resistors, you may be able to get that value, that particular value of resistance you need. In this problem, we just needed to take resistors that were in parallel and in series, and we made several equivalent diagrams using equivalent resistors to help us find the equivalent resistance of the combination of 4 resistors.